Mental health emotion detection is a powerful project for AI and ML students who want to build technology that genuinely helps people, and I want you to see how impactful this can be in real-world healthcare. Imagine an AI system that listens to someone's voice, reads their messages, or analyzes their facial expressions and understands whether they are stressed, anxious, sad, or emotionally overwhelmed. That is the core idea behind this project, and it uses simple NLP, speech processing, and computer vision techniques to identify early signs of emotional distress. This matters even more between 2025 and 2027, because mental health awareness is growing, yet many people still lack access to timely support. AI can fill this gap by offering continuous monitoring and early detection. You can apply the system to social media platforms, to flag distress signals, to therapy tools that help professionals track patient emotions, to corporate wellness programs that monitor burnout, or to telehealth platforms that analyze emotions in real time during online consultations. These applications make the project extremely relevant for companies hiring in mental health tech, telehealth, wellness platforms, and healthcare AI. Recruiters value this project because it shows you can work with sensitive data, understand emotional cues, and build AI that enhances human well-being. Understanding the skills needed for mental health emotion detection is important because this project blends NLP, speech processing, and computer vision, and recruiters want candidates who can work across these areas with confidence. And you begin by learning sentiment analysis, so the system can read text and understand whether someone sounds positive, negative, or emotionally distressed. You also study transformer models like BERT, because they help detect subtle language patterns related to depression or anxiety. Next, you explore speech processing, where you extract features like pitch, tone, and speaking rate to identify emotions in a person's voice. Tools such as LibROSA help you capture these variations in audio. On the vision side, you learn facial expression recognition, micro-expression detection, and facial landmark analysis, using libraries like OpenCV and DLib, which help the AI interpret nonverbal cues. These three skill domains form the foundation of emotion detection. You also use frameworks like Hugging Face, PyTorch, and TensorFlow to build and train your models. For text, tools like SpaCy and NLTK help with pre-processing. Along with technical knowledge, you need strong understanding of mental health terminology, ethical AI practices, privacy requirements, and bias mitigation. This project teaches you to work responsibly with vulnerable users, and recruiters value these skills because they show you can build AI that is technically strong, empathetic, and safe. When you build a mental health emotion detection system, you need a clear roadmap because this project involves multiple data types, and recruiters want to see that you can structure complex AI workflows from start to finish. You begin by choosing your detection modality, which means deciding whether your system will analyze text, voice, facial expressions, or a combination of these. This choice depends on your use case and the kind of data you can access. Next, you gather training data from mental health datasets that include emotion labels, facial expressions, or depression indicators, and you handle this information with extra care because it is sensitive. Once you have the data, you move into core model development. For text, you fine-tune models like BERT so the system can detect emotions and signals related to mental distress. For voice, you extract acoustic features such as tone and pitch to train classifiers. For faces, you build CNN-based models to recognize expressions. Then you combine everything into a detection pipeline that includes pre-processing, model inference, confidence scoring, and alert mechanisms for critical situations. After this, you test the system ethically by checking fairness across different groups, validating your approach with mental health experts, and ensuring safeguards against misuse. Finally, you deploy the system with encryption, continuous monitoring, and user-friendly interfaces. Beginners usually take 8 to 12 weeks, while intermediate learners need 5 to 7. Completing this roadmap shows employers that you can build sensitive, reliable AI systems for mental health care. This project creates strong career opportunities because emotion-aware AI is becoming essential in mental health support, telehealth, and wellness platforms. and companies need engineers who can build systems that understand human emotions in a safe and responsible way. When you complete this project, you can target roles such as mental health AI researcher, emotion AI engineer, or healthcare NLP specialist. These positions focus on building advanced detection models that analyze text, speech, or facial expressions, and they often require the ability to work with multimodal data. Recruiters expect you to understand mental health indicators, follow ethical AI practices, and handle private information carefully. They also look for cross-functional skills because you may collaborate with psychologists, clinicians, or product teams. Your resume becomes stronger with keywords like emotion detection, effective computing, sentiment analysis, and multimodal AI. Companies like Wubat, Weezah, Ginger, Talkspace, BetterHelp, Spring Health, and several telehealth startups hire engineers with these skills. Salaries are attractive, with freshers earning 8 to 16 lakhs in India and professionals with a few years of experience reaching 18 to 32 lakhs. In the United States, entry-level roles often range from $90,000 to $140,000 because this field requires niche expertise and deep responsibility. Building this project shows that you can create AI that supports real human well-being. Start building this today and put it on GitHub.